Welcome to the presentation of Mashup and Data Visualization by Supergroup 5 Surprise Movie Platform. Firstly, we're going to remind you of the overview of our company's mediated schema to be propagated. Then briefly we will describe our source and its API. Afterwards, we're going to show you our procedure of loading new movies from the API and generating data. After successfully propagating our movie database, we're going to show you our fancy web interface and its main features. Finally, in order to better support our managers' business decisions, we also leverage the external visualization functionality of the Google Fusion tables. Let's begin with the schema overview. After a thorough initial analysis of our mediated schema, we decided to categorize our tables into three parts. The first category consists of the tables that are suitable to be propagated by the API. These tables mainly recorded the information of a variety of movies, which are movie genre, language, artist, role, and movie artist. The second category consists of tables mainly related to our cinema operation. The following tables are required to be generated by ourselves: view, mark, customer, ticket, plan, movie plan, and movie version. Finally, the rest of the tables like cinema hall, hall mode, etc. will remain unchanged, as the data there is already sufficient. Now, moving on to the description of the source we've chosen and its API. Here you can see what the main web page of the API looks like, and we're also sharing the link to it. There is a wide range of APIs that could be chosen, but we stopped on this one. Why? It has everything we need. The API provides us with the ability to search for movies by title, to get the cast and crew information for a specific movie by its ID. It is possible to get a list of valid jobs, which is very useful for us since it's necessary to fill the role table. We're also able to get the list of genres for the table of genres. It's important that the server response comes in the JSON format, which is easily parsed within Java applications with the help of a third-party library, JSON Simple. Our next topic is the procedure of loading and generating the data. Now more on the order of populating our tables, the ones that require more data than they already had. The whole process can be divided into 4 sections referring to the following topics: movies, movie crew, clients, and booking. Some tables have to be populated at the same time, such as movie and movie genre, movie artist and artist, movie plan, and plan.
Now I'm going to show you an example of propagating movie table with data from API. Since it's a long process, we separate it to 2 sub-processes. Firstly, retrieve the missing values from API to fill up all the null values to solve the data quality issues in our database. And secondly, propagate the movie table with new movies. For the retrieving missing data sub-process, we firstly fetch movie with missing values respectively in our database, and then send a request to API, fetch the corresponding movie in API, and finally update the movie details in our database. Because when searching movie entries only by movie name in API may be somehow imprecise, if movie year in the information is also available as well in our database, we use the movie name and movie year at the same time to improve the query accuracy. After solving the existing data quality issues, the second sub-process is to get new movies from API. We filter the movies with bad movie information quality from API, and considering the responded movies might be showed in multiple pages. Afterwards, in order to improve the performance, we also made some slight optimization of the code. Firstly, we decided to submit multiple SQL insert statements of movie per page in a batch manner in order to reduce the number of times to establish MySQL connections, which is quite time-consuming to do it for every single statement. Secondly, we decided to prepare the matching array list of language name ID, genre name ID in RAM beforehand in order to get ID values faster. Thirdly, for languages that do not exist in the initial language table, as there is no language list containing both language English name and ISO code provided by API, we decided to use external ISO code CSV file as a dictionary to look up and add new language when necessary. This screenshot shows you the PHP code that are used to parse the external language ISO code dictionary and find the corresponding language English name.
Now have a look at the procedure of loading and generating data for the table's artists and movie artists. They are filled out simultaneously. There is a limitation of the movie artists table, which is that one artist cannot have two or more identical roles in one movie. The first point on our to-do list here was to retrieve movies. That included querying our source by movie name to receive the source internal movie ID, as well as querying the cast and crew information. We need internal the MovieDB movie ID because the method that returns the information about the movie crew receives movie ID as a parameter. The next task is getting the actors' information. The cast object only contains the actors. We get role ID of the actor from the database, remember it, and record information about each actor from the array into the movie artist and artists tables, if such an actor does not exist in the artist table. The relevant piece of code is displayed on the slide. In the crew array, apart from the personal information of the participant, there is also a job title. In order to record the information into movie artist, we get the ID of his job title from the role list and then record it into the database. While the entry is being made into the movie artist table, a check is carried out so that there aren't any entries where in one movie an actor has two or more identical roles. If the artist is new and was added into the database during the execution of our program, we calculate with which ID he was recorded in order to insert correct information into the movie artist table.
Now we want to look at our data in the web interface. So let's investigate our new data in a live demo. To display the data, we implemented a plain web interface. It consists of 5 different views. In the top, you can find a navigation bar to select every view: movies, artists, time plan, cinema halls, and a statistics view. Let's start with our default view, which illustrates our movies. Round about 3000 movies are in our database now. On the left hand side, you can see all the movies in a table. If it's necessary to get some information of the movie 300, for example, it is possible to select it here. When a movie is selected, the details toward that movie are displayed in the right panel. Jared Butler played in this movie? Didn't he also play in The Gamer or something like that? Let's investigate that. Let's look in our artist data. Let's have a look. First we have to find him. There he is. And the movie he also played in was actually The Gamer. And there's another movie I can recommend you, The Ugly Truth. What about our time schedules? Let's look at our time plan view now. Let's say we want to check the time slot on a specific date. Let's take this one. Now we can see what movies are running on this tape. This view could help the planners to review their actual schedule for this day. Unnamed Cinema 2 shows a lot of interesting movies. What movies are also running in the cinema hall? Let's have a look. Okay, here we can see our cinemas. This view is also structured like the movie and artist view before. On the left side, you can see our cinemas, and on the right side, you can see the details. A lot of movies are actually shown in the search cinema. Okay. The Hunger Games is also running in this movie, in the cinema, for example. And let's have a look at the presentation mode. Oh, this cinema can also show 4K presentations. Very nice. But I wonder which movie is the best rated movie in our platform. Let's have a look at our statistics view. The tables here list several statistics. First of all, the movies with the most sold tickets are listed. In our case, it's Las Vegas. One can also investigate the most preferred genre by each gender. Well, that women love drama is not really a surprise here. What else can we find here? Okay, our preferred languages. German is a quiet surprise in this case. And there is the table we are looking for. The best rated movies. Well, in our case, it's Dr. Zhivago. Surprise, surprise. This rounds up our short live demo. Seems like our data imports were successful.
Next, we are going to show you how to create some visualization in Google Fusion tables. Therefore, we decided to answer the question, how many movies have what original languages? The first step now was to choose the right tables out of our database and to upload them to Google Fusion tables. In this case, we had to upload the tables movie and language. With the help of the merge function, we merged both tables over the language ID. Now the resulting table contains all information we need. Next, we simply add a chart and do the configuration settings displayed in the right side of the shown slide. In our case, the best fitting chart for answering the question is a bar chart visualization. Choosing the right settings, category as language name, summarize data, count of the values language name, sort by language name and maximum category is 40, we got the result displayed in the two graphics shown in the next both slides. The first graphic visualizes the global view. Here you can see that by far most movies have English as original language. This slide is a zoomed in version to display the languages with lower numbers in a better way. Moving on to the geographical part, the main question was what geographical information we are able to retrieve with the help of the API for further visualization. We have agreed on creating a visual representation of the following statistics. The number of movies made in each country from 2010 to 2013. Fortunately, the movie database provides the production countries array for each movie. However, before populating our database with the information about the countries, several assumptions were made in order to solve the problem of null values. For those movies for which production countries are not provided by API, we have created additional verifications to define a country by its original language. For example, if original language is English, the country is by default the USA. In the next step, we have retrieved the necessary data for creating a map from our database into a text file with the help of a simple SQL query. However, filling polygons is only possible with borders for each square on the map are predefined in a specific format. Therefore, in Google Fusion Tables, we have merged our table from database with the KML file containing all the country borders and customized map features. Here you can observe map feature configurations. The result is presented on this slide. The leader of movie production is obviously the USA with the highest number of movies, 602. seems to be true, but the accuracy of data used is very low due to the fact that in our database we only have information about 2,000 movies, most of them from the USA. Moreover, the API has provided us with the production countries of about 60% of movies. Other countries were determined according to the assumptions. Thank you for your attention.